Eric Lindell, back again to talk about time after dental work. So blame the Novocaine if this doesn't come out right. Time has not just a direction per the last video, but it has a dimension also. It has one dimension and it has one direction. And that direction lies along that dimension. And the two concepts are so inseparable that they need almost the same word. And dimension and direction are almost the same word. Now, I have no doubt that they have completely separate etymologies, but there's something that I call convergent etymology, where words with similar meanings somehow just end up with similar phonetics and similar spelling. And this would certainly be an example of that. If you look at the phonetics of those two words, they have something like 8 or 9 phonemes each, and for a total of 17. And I did the math once, and I'm not going to do it again right now, but it's something like that. And of those 17 phonemes, I think all are shared in common except for 1 or 2, maybe 3. And not only that, but the order of the phonemes is almost the same. Okay, so you have the idea of dimension and direction of time, a concept in physics, philosophy, whatever you like, and the direction always lies along the dimension. So they are denoted by virtually identical words. I don't think that's coincidence, although when I raised that issue with a linguist, she immediately replied that it was coincidence, which is the answer I always get, on account of the fact that the words for dimension and direction in other languages do not sound similar to each other. And I credit her with probably a pretty vast knowledge of language, and I credit her with fast logic. That's a good argument. Unfortunately, it doesn't refute my argument. My argument, it may take away something from it, but it doesn't undermine my argument entirely, not by a long stretch. So, I'm lying down because the dental work was so stressful. And I've been putting off this video forever, so I figured, all right, you know what, I'm going to do it imperfectly rather than not do it at all. Because you know what they say about perfectionism? It's a form of abuse? Well, that's one theory anyway. Scratch a procrastinator, get a perfectionist. If you want to get things done by a deadline, you got to drop the perfectionism. Okay, so that's my spiel about direction and dimension. Now, the other thing I want to talk about is that space has 3 dimensions, classically speaking. Forget these, newfangled theories about, 10 and 26, whatever number of dimensions they have. And I want to talk about the comparative dimensionality, classically, of time and space. Why should time have only 1 dimension and space has 3? Well, okay, follow this argument. Imagine walking north, let's say 3 steps, and let's say 1 step per second, and you're snapping your fingers, 1, 2, 3, then on 4, you're going to turn right, which I guess is east. So you're walking north for 3 steps, east for 3 steps, boom, boom, boom. Okay, so your clock is ticking 6 times. 1, 2, 3, 4, 5, 6. a step is occurring on each tick of the clock. The first three are in a northerly direction. The last three, fourth through sixth, are in an easterly direction, which is a new dimension. Okay, north and south are all along one dimension. East and west are all along one dimension. They are two separate dimensions. But when you change the spatial dimension that you're moving in, that's the Novocaine, you're still in the same universe. You're still, on the same planet, on the same continent, on the same street, maybe. Why? It's because you did not change time dimension. Okay, you can change spatial direction without going into a different universe, provided you're on the same clock in the same time dimension. Okay, if, by contrast, you had started over with a completely different clock and a completely different time dimension, time scale, when you change direction spatially, you would have entered a different universe. Why do I say that? Because a universe is defined by its single axis of time. Everything in the universe is a function of time. There's nothing in relativity or quantum theory that can change that, although there's probably a lot of caveats to be added to that, which hopefully we'll get to. But the entire Big Bang, is just an unfolding temporally of, a gargantuan explosion. That's why they say you can't really, you can't blow up the universe because it's already exploding. Anyway, neither here nor there. So a universe is defined by its single dimension of time. You can have another dimension of time if you want, but it defines another universe. And the two can never intersect, because if they had any knowledge of each other, they would be the same dimension of time, and it would be one universe. Okay, so that's why space can have more than one dimension in one universe, because time cannot have more than one dimension in one universe. Now imagine, if you will, time having two dimensions. This would be a complete disaster epistemically, and you couldn't even proceed with, let's say, a geometric proof predicated on the idea that a triangle has three sides. Why? Because that definition may hold in one time dimension, not in another. This is the basis for the principle of contradiction, that it's impossible for a thing to be and not be at the same time, because there's only one time dimension. If there were two, a thing could be in one dimension and not be in the other time dimension at the quote-unquote same time, whatever that even means, without contradiction. You could not begin to make an argument about anything, because any assertion you make, like triangles have three sides, would apply in one time dimension, and it could be immediately contradicted by an interlocutor who would say triangles do not have three sides, because that's true in a different time dimension. Okay, if I say triangles have three sides, and somebody says no, triangles don't have three sides, I couldn't then say, how could triangles not have three sides if I just said they have three sides? That would be something and its opposite being true at the same time, But no, it's not the same time because he's in a different time axis, different time dimension. Okay, that's why we want to have one dimension of time, because with two, you cannot have this principle of contradiction, and the floor is pulled out from all epistemology. You're in a type of quicksand from which there can be no extrication, so it's best just not to go there. And if time had no dimension, then there would be an exception to what's called the principle of the excluded middle. Okay, now the principle of contradiction gets all the press. Everybody's heard of that a million times over. How many people have heard of the principle of contradiction, of the excluded middle? Well, precious few. Okay, I had to look that up because I kind of thought it up. It's sort of obvious if you think about it, and having thought it up, I just kind of went online and bada bing, bada boom, there it was, right there with the principle of contradiction, which says it's impossible for a thing to be and not be at the same time. And the principle of the excluded middle says that it must either be or not be at any given time. Okay, so the light is red, traffic light is red, or the traffic light is not red. Okay, it can't be both red and not red at a point in time. That would violate the principle of contradiction. But it must be either red or not be red at a point in time. You can't say it's neither red nor not red. It has to be one or the other. That's the principle of the excluded middle. Now, if you combine those two principles, that of contradiction and the excluded middle, you get the principle of bivalence. And I Googled 50 times to get the pronunciation of that, and I still don't know. So maybe it's bivalence, like ambivalence, but I'm going to call it bivalence. And this logic of contradiction and the excluded middle are the epistemic foundations for everything. And they are effectively synonymous with the unidirectionality of time, the unidimensionality of time. Okay, if time had two or more dimensions, you would not have the principle of contradiction, and if it had less than one dimension, that is to say none, you would not have a principle of the excluded middle. So that's why you have to have time with one dimension. You would have an utter disaster, epistemic quicksand from which there would be no extrication. And I call this the epistemic floor times unidimensionality. If you go beneath that floor and lift that assumption, you're lost. You cannot make any kind of an argument about anything, because any assertion you make can be contradicted. That is, in a nutshell, why time has to have one dimension. And goodness, there's so much more to say. I'll keep that for the next video. But gosh, thank you for listening. And if you're not listening, by the way, don't you think you should?